taking that power, but also taking the responsibility and making it yours and participate, not just consume.
The beauty of the future energy grid is that it will be smart, it will be decentralized, and it will have a multitude of various stakeholders being able to participate in the grid, but most importantly also being able to contribute to the grid. The huge headache of the future energy grid is that we'll have to make it smart, we'll have to make it decentralized, and we'll have to manage an insane amount of different stakeholders. So it's no surprise that a lot of folks are turning towards blockchain as the technology to solve a lot of these issues, because blockchain, of course, is known for being the decentralization tool par excellence. It's known for making it very easy to automate contracts. And of course, it's known for creating trust in a network with countless users that do not necessarily know each other. However, it's been suspiciously quiet around blockchain in recent months, I feel, after years of hype. So high time to see what's actually still happening in the blockchain area. How far off are we seeing from real applications, real useful applications being implemented in energy grids in the near future? And what are the plans for the long future? Stay tuned to find out. Welcome to the Smartery Podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. If there's one thing that the renewable energy community and the blockchain community has in common already, it's that a lot of people are very enthusiastic about engineering and technology, and on the other hand, they're idealists. And I think those two attributes are also a perfect description of my guest for today, Sebnem Rusitschka. Welcome, Sebnem.
Thank you. And you're spot on.
Yeah, I thought so. So just to introduce you a little bit, to let our listeners know where you're coming from. You're originally a computer scientist. You've worked in applied research of peer-to-peer computing, machine learning and smart embedded systems at Siemens for quite a while. And then in 2016, you founded Freeelio. In my own words, an open innovation community that brings together all sorts of different crafts, not only engineering, but also people with a background in innovation methodology. And you want to put this all together to basically make energy as easy, accessible, and as affordable as breathing air. Is that it? Just sum up?
Yes, thank you. It's so refreshing actually to hear this back. It actually for the first time that well articulated. Thanks a lot.
You're welcome. So thanks a lot. It was easy because I read through the landing page, and I think Freeelio has an amazing website, and it basically states your mission. We want to make energy as easy, accessible and free as air. How far are you from that vision currently?
Strangely, it seems super closer than ever. But when we look at its implementation or its practicality, it seems daunting. And quite far away. And maybe the reason is the one point you picked actually very well is, I came from a very technical and engineering focus where most of the technical problems seems to be solved. But now we're standing in front of this mindset issue, and that's a much bigger mountain than I thought. So, and that's actually also one of the things that blockchain in energy also faces. The adoption is not so much a technical problem, but much a mindset shift and adoption problem.
I think that is a wonderful issue that I would love to just put on hold for a second and dive into in a minute. And before we do that, I think this podcast is not long enough to explain the basics of blockchain, but maybe just if you sum it up in 1 or 3 sentences, what is blockchain about for those people who hear the word for the first time or haven't really read up on it yet?
Yes. So as you say, it's very difficult because it is deep tech. Definitely, it's multiple disciplines coming together. But conceptually, it surfaces, if you can imagine, a global distributed ledger that keeps track of balances and addresses, accounts, without a single authority to keep this data, the information on it, assuring its integrity. And that is basically the foundation of the decentralized revolution we are talking about again. It makes the value exchange over the internet possible.
And that, of course, just if I listen to you, there's a lot of attributes in there that perfectly fit a smart grid. So there seems to really be a relevant connection, which also, again, I'll put on pause just for a second longer. If you look at blockchain, generally apart from smart grids or the energy sector, what happened? There was such a huge hype for a couple of years, blockchain everywhere. At the moment, it's rather quiet. So is that a good or a bad sign?
It's always a good sign. It means we're down the slope of disillusionment or hit the bottom maybe, and it's only the curve of productivity ahead, right? So the story really is that we hit the reality of implementing, and that's a great issue. We know where the problems reside, and after this whole hype of blockchain and energy, we have put out the blockchain strategy for Germany, right? And it is full of wonderful, sustainable use cases focused on sustainability and energy. It's amazing how much there is in there. But strategy is one thing, implementation and tactical is the other. And that's where we hit a wall almost. It's about law and regulation, both on the financial regulations and energy regulation, the market design of energy that is basically only developed for one size, and that's big centralized electricity provision. And these are the problems basically that smart grid has faced for so long. And now, of course, also blockchain applications in energy face.
All right. So if I sum up quickly, the huge problems at the moment is trying to develop new tools, new setups in a market that has been mainly focused on utilities. And now you suddenly have so many more stakeholders, and it's a hard thing to make regulations catch up on the technological innovation and pace. You already dived a bit into the energy sector, so let's also lay out the large overview of blockchain's relevance for the energy sector. So where do you think, in which bit of smart grids and in the energy sector as such, does blockchain have something to offer that other technologies don't?
So, as mentioned, beyond this whole decentralization, peer-to-peer technologies that has been developing along since the 2000s alongside smart grid, this blockchain revolution, if you will, is really the revolution of programming rules how to exchange anything of value, keeping track of this exchange. And that basically allows us to actually program new market rules on top of the existing game, actually. It's also possible that enables new forms of and more flexible forms of decentralized electricity feed-in and consumption and sharing.
May I ask you for if you have three very specific examples, one maybe from a European perspective, what kind of people would be tied into such a system, one maybe for emerging economies and developing countries, because that's something that Freeelio also has a big focus on, and then maybe one that on a global scale bringing all of us together.
So one game changer again on regulatory basis is the European Energy Directive 2, which basically forces or pushes forward the renewable energy communities, meaning the energy sharing in local communities, that shall be unobstructed by current rules and regulations. And that is a wonderful scenario where we have basically the local setup of multiple energy sources and energy consumption sources, for example, solar rooftops, in industrial parks, household regions, etc., put together such that they can optimize their local energy consumption fully based on their local renewable energy production, including basically also mobile storage, which electric vehicles are, including storage and including combined heat and power. So I'm talking about many different energy sources, electricity sources of different sizes and different capabilities. And then also basically after the fact, energy sharing that happens on the power grid instantaneously. But after the fact, actually keeping track of the exact exchanged amounts for accounting and billing purposes, but also beforehand in the planning of all of it, actually keeping track of the potential of electricity exchange in those local regions. That's what tokenization and blockchain can enable.
So that was an example, for example, in a European grid. And if we look at emerging economies or developing countries, what kind of setups could you imagine there?
So that's what is really very promising, and that was for the longest time the hope that we will make real progress there, are true smart microgrids created bottom up, really from rural electrification projects where villages set up their own smart microgrids, from technology off the shelf but cutting edge smart grid technology, either put in small boxes that can then connect households into a smart grid, or in big containers.
So if I just imagine, it might be a bit cliche, but if I imagine a remote rural village in Africa, they maybe have a big shipping container with a whole solar setup on top of it. Maybe they have some smaller individual solar plants in their farms or houses, and then they all get connected and they sort of like leapfrog a whole grid setup that we usually would go through in Europe.
Exactly. So that it doesn't start to centralize and then tries to decentralize, but these decentralized setups per community that is living together.
Why would they then need blockchain in their grid?
So that's the point where it's not so much for a community that trusts each other. For them, actually keeping track of the exchange without having to trust is definitely lightens up the entire operation. But most importantly, the one aspect that really stood out was the financing of such projects, that basically we could prove that those projects are installed, active, and are basically providing electricity as advertised. And you can keep track of all this information and data in a privacy preserving manner on a decentralized ledger. That was the light at the end of the tunnel, if you will, that we wanted to capture.
So if I just rephrase it, if it's, for example, you have a project, you have a company providing these containers fitted with a solar rooftop, but then you need investors, maybe crowd investing, these kind of projects. And then for the investors to really know, okay, that shipping container was actually built, it was actually sent to Africa, and it's actually producing energy for the locals, to keep track of that in an uncorruptible way.
Yeah.
Okay.
And technologically, this is the value add, if you will, of a global ledger that keeps track of these physical and digital assets.
So there we already have a global application of blockchain, meaning, for example, connecting investors in Europe or in the US or China with, for example, in that example, with a project in Africa, if you will. And then apart from that, is there also a global application of a blockchain, or will it always be more regional because energy grids tend to be more regional?
Well, actually, the value add of a blockchain or tokenization only is realized when you are at the global level, because on the local and then community level, you don't need that type of security, if you will, decentralized keeping track of value, because you naturally have this also social norms, etc. But when we would want to scale the financial side of it, that is where it still makes a lot of sense. But how do you bootstrap this global financial layer for decentralized clean energy access everywhere? How to bootstrap that, again, is a hang up on the human and mindset level, because we're introducing a technology that people don't know and don't trust.
And so we come back to the mindset shift that's necessary that you spoke about in your introduction already. So what's the problem there? They don't trust the technology yet. They don't understand it. It's too complicated, or?
Exactly. And with they, all of us basically, and also as with every technology, that will need maybe 10 years to become an overnight success, right? So we will need to see its development and adoption in, less risk-averse fields. That's definitely my takeaway after 5 years. And basically also it's the development of, the interfaces using this technology need to become much more safe for mainstream user. Currently, you really need to have experience with keeping your private keys safe and so on. So at that level, you already see when we have people struggling with passwords to their mail accounts, etc. It's just a very big difference to this technology being adopted.
So just to break that down to an example that also the unversed blockchain listener can understand is that if, for example, I partake in a blockchain scheme, let's make it very simple. Let's say I buy cryptocurrencies and then for example, in my own experience, I get like a hash key, which consists of a long string of numbers and letters and is far more complex than the usual mail account password. That's 1, 2, 3, 4, 5, 6, 7, 8. And
hopefully not.
Hopefully not, exactly. But that makes it very difficult. So I think a lot of different layers are in there. If you want to build blockchain into a system, it's probably very hard to actually find the experts who are actually able to do it. Then it's probably, as you said, very difficult to run it and maintain it. Also because on an operational level, the interfaces are probably not very smooth yet. And then if you come to a purely B2C level where, for example, I plug in my Polestar at home and feed energy back into the grid. And if I need a specific access key there because it's a blockchain, it becomes very difficult on a B2C level to just operate it very foolproof. Is that correct?
Exactly. And actually, that's also the paradoxical logic of it. Basically, there shall be no B2C. It's a C2C. It's literally everyone who can participate actively in a network able to participate actively in the network.
Oh, I get it. What you're saying is that I would not see myself as B2C because I'm actually producing and selling something. So I turn into a B, meaning I turn into a business partner in the scheme.
If you will, yes. And basically, every time you need a service provider to help you do something, right, that's where you can very well question the rationale of actually using blockchain or tokenization, because you have been trusting a centralized party.
So, Sebnem, what I would like to ask you, apart from all the use cases that we heard about, a big thing, obviously, with blockchain is that there's different modes of running it and the approaches it uses. Some of them are very energy intensive. And it kind of like seems to be not so logical to employ an energy intensive blockchain in a grid that is built to save energy and be as efficient as possible. So why are some blockchains so energy intensive, and what are the ones we need to use in energy grids if you want to be efficient?
Basically, what I always used to say and still say with a bit of a joke is that it's actually great that they use so much electricity, because all of a sudden people are questioning the energy consumption of other things like their flight or the big, factories in their vicinity, etc. However, of course, you're right, like Bitcoin, for example, assumes really a global ledger that cannot be corrupted. And for that, it uses a mechanism to actually keep the data integrity, as I mentioned early, which you can call a consensus, meaning every node, every computing node in this network is keeping track of the same information and makes the same consistency checks, and the majority basically agreeing upon that determines the data point that is in check and consistent with the data integrity. And that is very wasteful of computation, and wasteful of energy. But as long as it pays off, right, that network will be kept running and will keep the data integrity on it. So it's very powerful, very wasteful, but very, very powerful. However, there are also other blockchains that use other technologies, other methodologies of, agreeing on the current data integrity on it, as well as there are entirely other solutions that you cannot even call blockchain anymore because they are using a completely different way of keeping the data integrity on it. So like proof of stake, I don't know if it will be of any help if I just use the terms.
Oh, I think it will, just if, so to our listeners, just to learn a little bit of vocabulary, and I think it really makes sense to read up on it. If you reference cryptocurrencies such as Bitcoin, usually they have a proof of work concept behind it. So as you described, just the sheer electricity bill you would have to pay in order to crack in my own words, very simple words, to crack the Bitcoin code, so to say, would not be worth it. But there are other methods to make it secure, such as you said, proof of stake. What that is exactly, I think listeners will have to Google. But there are other methods, maybe that's the sum up, there are other methods that are less energy intensive, and those are the ones that we want to employ in a smart grid.
And for example, in the energy sector, we have definitely one that is energy web. And energy web chain is basically a proof of authority, meaning the instances or the entities that validate the data on the blockchain are well known. And they have, again, a stake in keeping the validity of it. But for example, if you think, what type of parties, entities are actually providing that validation, it's, for example, the big oil companies and so on. So it kind of, we live in this strange world where, we see a lot of contradiction coming out, and I believe that's a good thing. And running every consumption on renewable energy sources, any type of consumption, that also becomes visible that that's the only sensible path forward, right? Because it's very unlikely that we're going to have less electricity consumption in our more digitalizing economies and ways of life.
Which, by the way, I think is one of the most important points around all of these kinds, whether it's electric mobility, whether it's blockchain or digitalization. Because a lot of companies just switch to a renewable energy provider and say, okay, now our product is net zero, which is just not true, because there is not enough renewable energy in this world. Energy demands will rise, so it's not enough to switch to a renewable energy source. You have to be as efficient as possible, I think.
Energy efficiency on top.
Yes.
Yeah.
So I think we've covered almost all the topics, and we're already out of time. So let's try to sum this topic up. I think that's the most challenging wrap up I ever had in a podcast. What were the couple of points you raised? There's different use cases for blockchain in a smart grid, whether it's just as the technology used to handle all the different stakeholders in a local smart grid, such as you said in Europe, for example. You have the car owner, you have the owner with the rooftop, with the solar rooftop, you have the utilities mixing in there, you have other energy sources, somebody with a wind turbine, etc., etc. Then there's financing schemes, as you said, for example, in setting up decentralized energy grids in developing countries in order to make all of the financing of these grids transparent, incorruptible. Their blockchain can be used. And then on the long run, it'll also have its validity and just managing everything.
Managing everything that, keeps track of numbers, basically.
That keeps tracks of numbers, that keeps track of values, and that keeps track of a lot of changes in very short time. I guess that's the biggest thing. Now that you have so many more stakeholders than we used to have, and suddenly they're not only energy consumers, but suddenly, as you mentioned, they turn from consumers to business partners because they feed back into the energy grid. And that's the challenge that we need to solve. But I think one of the most important things, as you said as well, is that there's a mind shift necessary, because that's a completely different way of setting up an energy grid. You need to adjust regulations, you need to adjust the mind shift, and you need to instill trust in a technology that's there to instill trust, but it's so new that people first have to get used to it.
Exactly. It's really on our hands, on the side of the consumer, that needs to become much more, participate in that of which they are consuming, which they can be producing, right? And that demands very different, taking that power, but also taking the responsibility and making it yours and participate, not just consume.
Well, I think that's a wonderful closing statement I'd like to keep. Yes, do not only participate, but take that power that you have as a consumer and start shaping the smart grid of the future. Thanks a lot, Sebnem.
Thank you, Sekes. It was a pleasure.
The pleasure was all ours, and I hope that we made blockchain interesting enough for everybody out there to Google it, because it is a topic that you cannot cover in 20 minutes. So off you go, everybody. Hands on the keyboard. Start Googling smart contracts. Start Googling proof of stake or proof of work, for example, and dive in there. Stay tuned for more episodes of the Smarter E podcast. By the way, all our German listeners can find more information on the role of blockchain in the energy market at Forum Neue Energiewelt on September 23rd, 2021. Info on the conference can be found online at forum-neue-energiewelt.de.